SwayamPrabha. Digital India. Educated India.
Hello everyone, welcome back to NPTEL online certification course on research methodology for planning and architectural studies. So far we have discussed many aspects of research methodology. Also I have shown you some of the case studies where researchers they have used the qualitative and quantitative techniques to solve their problem. They fulfill the research objectives. Even in last three lectures, we have also discussed about the recent advancement trend in all this application of big data analysis, use of simulation in architecture and planning research, and also the application of artificial intelligence in research. Now, today we'll be discussing another interesting topic, and this is something very important in today's world where we are approaching towards handling lots of data, and to analyze that data many a times it is not possible or it is taking so much of time if you do it manually. So we take help of softwares and also the programming language to solve it in quick time and also with quick precision. So there is always a pivotal role of this programming language and also the software that are being used in the field of planning and architecture. So with that, today we will be discussing lecture number 59, Programming Language and Software for Research in Planning and Architecture. The objective of this particular lecture, what we are going to learn from this lecture, these are as follows. First, we will discuss about very basic, the idea of programming language and software and how they help researcher to speed up the work and also come up with good findings through meticulous analysis and also handle lots of data in quick time. We will be discussing about the benefits of programming language and software in the context of research in planning and architectural domain. We will also discuss about the software for research in planning and architecture. We will discuss about programming language for research in planning and architecture, and along with that, though there are so much of advantages of using programming language and software in conducting research in planning and architecture, so there are certain issues, challenges that as researcher we should also understand. And then we will summarize our understanding towards the end of this lecture. Now, so far the programming language is concerned, a programming language is a formal system used by developers to instruct computers. Now, computer in the field of architecture and planning probably we all are aware of. We must have used computer for writing report, we have used it to making presentations, we have used it to creating charts in MS Excel, or maybe in some cases like in our undergraduate degree whether it is BARC or B-Plan, we have used various softwares, right? And some part of our education we also try to understand about certain languages like C, C++. Maybe the application was not that extensive in the context of planning and architecture, that was like maybe the school day exercises that we have solved. But the same language, if we can develop, if we have that expertise, or we can also take that help of different forum and other expert to develop certain sort of code algorithm which can solve many complex problems. Now, this is something where definitely the computer plays a crucial role. So basically whenever we try to instruct computer, it is not just we instruct something by writing text or just orally we are saying something and something is performing. Even today it is possible, like speech to text kind of software, or maybe text to convert it to a editable word through OCR. Those are possible, but these are uh, you know only possible when we use certain software. But to develop that software, there is some programming. So either we develop our own program, or else we use certain software packages which is based on certain programming language, and developers who are good at it, they develop it for the users. Now basically it is a formal system, and this is used by developers to instruct computer, and computer will do either the computational thing, or it may be a visual rendering that can give as output. Programming language serves as an intermediary between human readable instruction and machine executable code. So this is in between, like wherever the programming language bridge that particular thing, like from the instruction, the prompt it convert to which computer can understand, those kind of ASCII or Unicode characters, etc. And then whatever computer generates, this will again transform it to a readable output or visual output. In the same line, the software refers to a collection of programs, as I already mentioned, that even if we can do this, like now in today's time, whenever like many of us, we are aware of those kind of chat GPT or maybe AI generated images or videos. So in those cases, we just write certain kind of text, and we can say these as prompt, and with those prompt it is creating some sort of text, or it may be images, it may be some sort of videos. But those are possible because there is some sort of programming at the back end. We never understood that part, or we never bothered to understand that particular aspect, that how it is converted. We only give certain input and we are getting some output, which is our main purpose to get. But as a developer, say I would like to understand what is happening, like whenever I say that give one image of sunset, and how it is going to give us the same. So there is some sort of programming happening, some languages, some algorithms are set at the back end so that it can give the actual results. Still it is in developing stages now, where text prompt and answer creations are still in practice, and it is like many developers they have come up with. There are certain sort of updates that are also coming up, in also something the application of AI in voice, application of AI in video creations. But in those cases, the software that we are using, like even if it is the Photoshop or it is AutoCAD, so there is some sort of programming language that actually made that interface to the users, so that we can very easily can pick up the tools and we can do all our needful. Now in the software, all these programs will help in some sort of data storage, data interpretation, and the instruction that enable a computer system to perform specific task. So to draw a line in AutoCAD, so we pick up the line tool, and then we start a point and then we end a point. We can also use the keyboard shortcut for that. But to draw this line, all this kind of logic behind that, the straight line that should have all this kind of collinearity of all the points in between. So all these algorithms are set at the back end, so that we can only use that particular tool or the keyboard shortcut to create it. We don't need to write any comment on that. Software encompasses both applications and system software. Now let us discuss about the benefits of programming language and software, especially when you are conducting research, some experiment in planning and architectural domain. The first one is the automation. Programming language allow researchers to automate repetitive tasks such as data processing, analysis and visualization. Now, if we have large set of data and we need to remove certain sort of missing data or duplicate data and all, we can manually do that. Say for example, if I provide you 10 data points and out of that you have to remove say 2 duplicate data which are there in that data set, you can very quickly do that. Now if I make this number 1000, it will take time. Now if I think of a data which is of say 1 lakh data or 10 lakhs data, 1 million data, can you do that? So answer is yes, you can do that, but it will take time and it is very much monotonous to find it out, and then maybe one can make mistakes to handle this much of data. But whenever you have certain platform and you have certain algorithm to find it, with few seconds you can get which are the duplicate data, and in next click you can also remove that so that you can get that information in order. Now say whenever you have some text, okay, and from there you need to make it in a table. So it is text to table or table to text, which can easily be done in Excel with certain available tools. But if you want to do it manually, even if it is a simple copy pasting exercise, but it will take time, and somewhere if the things are repetitive in nature, even that will take time, and also that will not be a pleasant thing to a researcher to do the same thing again and again. So for that, this kind of programming language and software can help us to do the repetitive task. Coming to the data analysis, programming language like Python, R, MATLAB, there are many. So to name these three, because they are very frequently being used by researcher, not only in the domain of planning and architecture, everywhere in all the disciplines. So this Python, R and MATLAB offer powerful tools and libraries for data analysis to understand complex pattern and trends. Not only the particular platform, but also it has extensive library. So already the developers, they make certain sort of kind of library, the prototype, so that you can take that, you can start that particular point where the developer actually already demonstrated. You can start from that point and then you can customize it as per your need. Next is the modeling and simulation software tool like Rhino, which is a short form of rhinoceros, Grasshopper, then Simulink, along with programming language like Julia, Python. They enable researcher to develop models and simulation. So this is something where you have some software and also certain languages, so that you can develop sort of customized plugin which can solve the purpose. And that is something making a bridge, because the software that you see, it's nothing but a programming behind it. Even you play some online game, so there is some coding behind that. So if you can alter this, so that you can create a different scenario as and when required for your research. Now customization, already I have mentioned that the programming languages provide researcher with flexibility to customize algorithms. You can use the libraries and then you can customize it based on your need, and also you can customize the models to suit the researcher specific research objective. So in this particular case, if your objective is to do something, you find that some sort of library can be best suited for your case, you start with that, you use that library and then customize the algorithm, and then you can use it for your research purpose. Next pointer is the interdisciplinary integration. Programming languages and software tools facilitate interdisciplinary collaboration by providing common platform for researcher. So as I already mentioned that whenever you develop something with those kind of programming platforms. So there are continuous development. The enthusiasts, the developers, they keep on updating the program. They are trying to solve different, complex patterns, certain issues uh, through those kind of, coding and programming. Now whenever you use those platform, you can always interact in that forum and you can get many idea. Whenever you stuck to certain uh, stages of your programming, you can always put up those things in the forum and you may get help from different researcher who are using the same platform. So in that way you can also make certain sort of collaborative effort to make your research successful, and basically it will give the platform or background to work together. Coming to the next point, which is of the reproducibility and transparency. So whenever you use certain software or program, if it is like followed, especially for the programming, if you have followed the rules and if you can able to make the algorithm correct, so even if that particular uh, programming algorithm is used after a certain time and you have the same data set, so your result will be same. So that is something, giving some sort of transparency that okay, this is the data set, this is that particular program, or this is that model or algorithm that I have developed. Now anyone can check it to validate. So as a researcher or maybe somebody who will try to follow your work will get a chance to validate your findings with those kind of programming. So that's why it promotes the reproducibility and transparency in research, allowing other researchers to verify findings, build upon existing work, and also contribute to the advancement of the knowledge. See, if something is already developed for certain purpose, so that can help the other researcher to start from that point and enhance it, to extend it, rather than just repeating the same thing. Next is the scalability. Programming languages and software tools are scalable, allowing researcher to analyze and model large scale system and data set. That is possible nowadays. Now coming to the cost effectiveness, you can say that some of the software is very costly, okay, and definitely cannot use it. But many programming languages and open source software tools are freely available, which you can use, making them cost effective options for researchers, especially those working in academic and non-profit settings. So if you even search for all this software, there is always some sort of student version. There are certain limitations, but at least to get some hands-on idea for this particular software, you can use it. So sometimes if you find the software are not available, it is very costly, you can always look into the programming language which are available, which are open source, and you can develop such kind of functions which you require. Innovation and creativity. Programming language and software tools provide researchers with tools and resources to innovate and push the boundaries of traditional research. So some of the things that when we talked about in recent discussion about the virtual reality, augmented reality, so those are the things are possible because of this programming language and the software. Otherwise it's all like, as I already mentioned there, that earlier whenever we have to show certain kind of city plan in some sort of 3D visualization, we used to make the sketch or we just make a model, block model or detail model. But now you can go for some sort of very detailed realistic model. We will discuss that in our next lecture as well, about the digital twin, where we can just create the things digitally which is similar to the real world scenario, and then you can do the analysis and then you can implement the changes wherever you require in the real field. Now we will be discussing some of the very common programming languages that you can use, though if you do not have expertise in it, but now in today's time whenever you have the access to internet, there are lots of tutorial, lots of good short courses that you can go for if you are interested, and you can understand that how you can use those kind of programming platform or languages to develop certain algorithm and model for your research. The first one is the Python. Python is highly versatile, widely used programming language and suitable for tasks such as data analysis, visualization, simulation and optimization. Similar to that, R is specifically designed for statistical computing and graphics, making it particularly useful for analyzing data and conducting statistical modeling, and R is also a open source, so you can use it very effectively. Next is MATLAB, which is again one of the most commonly used programming language used across various fields of research. So, MATLAB is a powerful programming language and environment for numerical computing, algorithm development and data visualization. So, you can create interactive diagrams, and you can even solve certain sort of complex problem by coding into MATLAB. Similar to that, we also have another one, Julia. Julia is high performance programming language specially designed for scientific computing. JavaScript, maybe many of us we know this term, or somewhere we have used it before. JavaScript is often used for web based applications and interactive visualizations that can be used to create dynamic and interactive interfaces for displaying research findings or engaging stakeholders. So, say for example, you want to develop a dynamic questionnaire, or maybe you just want to develop a very beautiful dashboard of your findings, and there are certain sort of things you can change, and you would like to see the changes because of changing a parameter in the model. So, those kind of interface can very well designed with the JavaScript. Next one is SQL, the structured query language is essential for managing and querying databases that can be used to extract, manipulate and analyze data stored in a relational databases such as building database, or maybe you can say the geographic information system. So, from there all this metadata that you can use that, and then you can solve the problem that you identify. So, whatever your research objectives are and all, you can solve it. Next we have C++. C++ may be used in planning and architectural research for developing computational algorithms, simulation you can develop, or even if you plan to develop certain kind of software application that you can do with C++. Similar to that, Java is another very commonly used developing desktop and web based application, and can be used for developing custom software tools, databases, web based platforms, data management and visualization. So, similar to the JavaScript. Now, HTML and CSS, HTML which also stands for hypertext markup language, and CSS cascading style sheets. They are fundamental languages for creating web based content. If you want to develop a website or a dashboard, some user interface design, you can use it very effectively. So, say for example, you are conducting a survey and then you can develop it with using this. Now, definitely we are also using some sort of already built platform like Google Forms, or maybe some researcher I have found they are using certain other platform like SurveyMonkey and others. There are so many, so not name a few, there are so many, but with this you can also develop at your own if you bring certain sort of dynamics. Suppose you give some value and the user can see the resultant value, etc. Next we have GIS specific languages, where GIS definitely we are using, especially in the planning for all the spatial analysis. So, GIS specific programming language such as ArcPy is basically an integration of Python library for ArcGIS, may be used for automating geospatial analysis and data processing, and map production. So, you can create those kind of things very easily. Now, here in next few slides I will show you some of such application, and definitely if you are interested in this, I have also given the URL for all this images that I have picked up. So, you can go through that and can understand well. So, this is basically where the MATLAB and Simulink was used to understand the urban link and coverage analysis for a location, all this proximity, the coverage, etc., that you can use. So, in this particular study they have used certain sort of race tracing algorithm to find out, and here you can see that how it is creating some sort of maps which depicts those kind of proximity and different sort of coverage. So, this you can use with the help of this MATLAB, Simulink and other software, like you can integrate it. Now, coming to the spatial analysis, the remote sensing with Python, that is now probably you can see nowadays there are so much of application of Python into the spatial analysis. So, this is one representation of the change detection and time series analysis of a location, where you can see this heat map, and this is a change from 1985 to 2021, how this particular land cover that has changed over time, and this is definitely you can see a river, and then this is the in between island that are formed. So, how it has changed over time. Now, coming to the data analysis and visualization in R. So, in R this is something, as I already have mentioned, similar to other statistical software that we will discuss later on in this presentation. You can use it. Here also you need certain sort of coding, but you can use the library as well, because already there are certain sort of inbuilt library already available program. You can use it, and then after that you can create those kind of tables for different analysis. Like here is a visualization, the R is very useful to create very beautiful graphs and chart, and you can see the scatter plot, you can see the stack bar. Here you also have some sort of area diagram, then the box plot. Now, you may say that these kind of things can be also done in Excel. So, yes, this is also possible. Even Excel is one of the powerful, you can say that kind of a software where you can do many things, many statistical analysis you can perform, and it is developed a lot. Like in last 10 years the data analysis part in Excel has improved a lot. You can use it, but R can also help you to do something more, because it is specially designed for the purpose of statistical analysis. You can perform certain different tests where probably Excel cannot give. But you have other softwares like Stata, or you can use something like SPSS, etc. Now, interactive 3D urban planning analysis using ArcGIS and JavaScript API. So, where you can actually through this JavaScript API you can analyze, and this is so much of dynamic in nature. You can change certain parameters, you can change the timeline accordingly. This map will give you the interactive thing. So, it is something again I am giving you the example, like this is sort of a dashboard. Like during the COVID time also some universities, they have developed those kind of dashboard about the COVID infected area or the number of cases, and there you can customize, you can see that within the country, within the district. So, those kind of things can be done through the help of your GIS application. It can be done in any GIS software, and also with certain sort of JavaScript or other language API to interact. Now, coming to the software for research in planning and architecture. So, I just mentioned some of them. Maybe in this case I miss out something which is still you are using, but that does not mean that those are not useful. Definitely they are useful if you are using it for certain purpose, but these are very commonly used software. So I thought to mention some of them. Like AutoCAD, it is widely used computer aided design software for 2D and 3D drafting and modeling. Again, the AutoCAD, like when initially I started using it, was having very little options to do with the software. But now in current time, you can do so much of modeling, and even you can do good rendering as well. SketchUp is 3D modeling software for conceptual design and visualization, and then also some plugin if you can use in Google SketchUp, you can create beautiful renders. So next one is the Revit, which is the BIM software for architectural design and construction documentation and analysis. Then we have Rhino, which is again a versatile 3D modeling software for complex geometric forms and parametric design. Grasshopper is again a visual language for parametric design and generative model. Now, in this particular case, in this GIF image, you can see that this form, which is a multi-story building that has created with certain functions, certain activities, and by changing the function, how you can alter the form of the building. So like that, you can see that by changing it, definitely you fixed other parameters. Now when you control all the parameters, so you can see finally what is the output. So for each change you get one set of design. So that's why it is a generative modeling. So you can generate a number of options very easily through this. You don't need to draft again and again, you don't need to make the model again and again. You can use with that change in parameters that you considered in that model. ArcGIS is a GIS software, the Geographic Information System software for spatial analysis, mapping and visualization, and where nowadays it has lot of application for GIS. And even if you are aware of that different master plan that now different agency they are making, that is also GIS based master plan, because then you have those kind of metadata and database that you can use for different purposes later on. QGIS is an open source alternative to ArcGIS for spatial data analysis. So it will also do the thing. Maybe ArcGIS will have much more tools, advanced analysis tools, but QGIS can also give you. And now when you use QGIS and add certain sort of API, it will be again very much powerful to do some kind of complex analysis. Then you have Adobe Creative Suite, which basically used for all these graphic design and visualization and presentation material. Energy Plus is a building energy simulation software where energy performance analysis can be done, where changing the roof, changing the overall envelope. So we will have that kind of options. So Open Studio is another building energy modeling and optimization software that you can use. Space Syntax, this is the tool for spatial configuration analysis and certain pedestrian accessibility measurement, pedestrian movement patterns. Synthesis is a parametric urban design and spatial analysis software. 3ds Max is basically one of the popular 3D modeling software and rendering software, which can give you realistic images, and it can also help you to create certain sort of visualization, animation, walkthrough, and also virtual reality experience. Lumion is another real-time 3D rendering software creating immersive architectural visualizations and presentation, which you can use as a VR input as well. City Engine is a procedural modeling software for generating realistic urban environments including buildings, street, landscape. Strata is a statistical software used for data analysis, regression, modeling of different variables, econometric research in urban planning, policy, etc. Transcrat is another GIS software which help to do some sort of network analysis for the transportation. and traffic simulation. SAP 2000 is the structural analysis and design software for modeling and analyzing buildings and infrastructure projects. Now ETABS is another very useful software for structural design and structural performance, especially for the high-rise building, which also includes the feature of seismic performance. Now when you just classify some of them and very commonly used software, statistical software, we have this SPSS software, we can also use Minitab, we have Design Expert, then you have JMP, we have Stata, Excel, and again what I am saying that naming only these 6 does not mean that these are the only good software available in the market. The list can be many, but these are very commonly used, which are being reported by the researcher in their papers. So I thought to say about this. Now coming to the simulation software for research in planning and architecture, we have Stella Architect, where we can make certain sort of analysis for system dynamics. We have PTB VSIM, which is often used in this VSIM software for the traffic simulation, the micro simulation that you can see here, this kind of analysis. MATSIM is for multi-agent transportation simulation. You have Energy Plus for energy simulation software. ETABS already have mentioned the structural performance simulation. Fine. So now we understood that there are certain sort of importance, and if we can use those software and language effectively, we can do many work in short time and with much more accuracy, which will have the property of reproducibility and transparency, and also this can reach to the other researcher very effectively. The validity of the result will be also much more higher compared to a traditional research through a manual intervention. But there are certain challenges of using this programming language and software, especially if you start with the steep learning curve. So complex interface and technical requirements can hinder the adoption. So whenever I say that Python or say JavaScript, they are very useful. But we have to understand that the way especially the students in architecture and planning, the subjects that we have learned over time, we did not probably focused on those kind of writing codes or languages, making algorithms to solve the problem. We mostly use certain software. So there is certain sort of issue that when you think that even if I know that this particular programming language can help me to do that, but to learn that, to invest time, many a times it actually make that kind of a hindrance, and then it is a slow adoption. Compatibility issue, integrating different tools and ensuring data compatibility across platform is again a problematic thing, especially when you have certain sort of system issue, because some of the software, the graphics software needs certain requirement. To do that, you need certain graphics card configuration, certain RAM configuration, which you may not have. So for such kind of cases, there is some sort of issues. Limited accessibility, costly and proprietary software may restrict access, particularly researcher with budget constraint. So that's why I cannot simply say that okay, some good institutions probably have those system software available, but for the researcher who are having very low budget, maybe in those cases they cannot avail that. But as I already mentioned, there are some alternatives, there are certain open source software where you can use it. Data quality and availability, ensuring data consistency, validity, availability can be time consuming. Algorithm selection, choosing suitable algorithm for analysis, modeling and simulation requires the expertise and that kind of confidence. Unless otherwise, if I get a lot of library and I keep on then trying one after another, and then probably we cannot able to find the most suitable one. So for that we need to understand that what algorithm will be using for our own research. Performance constraint, the software limitations may hinder the scalability and performance with large data set and complex simulation. So say it depends on what type of software that you are using, and when I say that you can use the open source software or maybe the student version, academic version of the software, they might have certain limitation. So that is something a challenge. Version control, as because software is nothing but certain sort of programming where developer are updating day by day, and it's keep on updating from version 1 to version 2, etc. Many a times that version control is very difficult. Security and privacy, handling sensitive data requires adherence to the security protocols and the privacy regulations for the data that you used. Maintenance burden, keeping software updated and troubleshooting issue can disrupt the workflow, and many a times you find that the software that you use now it's no longer be that much effective in the research community. The advanced version is there, so that's why there are certain issues may come. Resistance to change, so this is something some researcher may be hesitant to adopt the new technologies, leading to inertia and slow adoption, because this is something we slowly moving to this, as I already mentioned during our previous lecture on artificial intelligence and all. Still we don't know exactly how we can use it effectively. Many of us, we just probably get those ideas from different media and all, that probably AI is the future, AI can do so many things, AI can replace the human manpower, etc. But unless otherwise we know it properly, we cannot take a call. So coming to the summary, so here we have discussed about what is programming and how software can help us. We have discussed about the benefits of programming languages and software, especially in the context of planning and architecture. Then I have mentioned about some common and very widely used programming language for research in planning and architecture. Then we discussed about software both for statistical, visual and also for simulation purposes for research in architecture and planning. And then at the end we have discussed several challenges that to deal with the programming language and software. But if we know that this particular programming language or software will give us a good result, so there is no harm to try or attempt to understand that language or the software very well. Maybe we have to invest some time for understanding it, but later on you can definitely use it very effectively. It can solve so many problems in quick time. It can save time to conduct your research in an effective timeline. So with that we end here. These are some further readings, and with that we'll be coming to the last lecture of this entire course, and there I'll be discussing some of the emerging research potential in planning and architecture. So thank you for joining. We'll be meeting soon with our last lecture of this particular course very soon. Thank you.